Welcome to Raw Perfect classes. In this video, I will discuss important questions related to discrete structure, in which I will discuss about graph theory, discrete mathematics, etc. and some questions about data structure. Now, first of all, you have to keep in mind that what is a data structure? A data structure is a storage. A data structure is a storage that is used to store and organize data. That is used to store and organize data. It is the method. It is the method of arranging data on a computer so that it can be accessed and updated efficiently. But a data structure is not only used for organizing data, it also used for processing. It's used for processing, retrieving and storing the data and storing the data. There are different basic and advanced types of data structure which are used in almost every type of program or software system which has been developed. So we must have good knowledge about data structure. There are different types of data structures. There are different types of classification of data structure which are already I have discussed in previous videos. If you want to know, then you can watch those videos. In this video, I will discuss questions and related to concepts and detailed explanation of each and every concept and questions. These are most important questions according to your competitive exams, according to your college exams. Now, first question is, which of the following graphs is or are planar? We have to find out of these three graphs, which graph is planar. Now, first of all, you have to keep in mind, what is a planar? What is planar? Planar means when number of edges do not cross each other and draw a graph. When number of edges do not cross each other and make a graph, that is known as a planar graph. So, in this question, answer is option C is a planar graph. How? Now I am going to discuss about it. How it is a planar graph. First reason is that graph 1. This graph is given in the form of K33, which is a well-known non-planar graph. Because if you want to draw new graph, from this graph, we cannot draw. You can see here. You can see this is a 3 by 3. We draw this graph. I draw lines from each node which connect with each and every vertex. You can see I can't draw such type of graph which has edges do not cross each other. So that's why this is not a planar graph. So this is a non-planar graph. In second graph, you can draw it. You can take here like this. You can draw from these vertices a new graph. So like this, you can see here no edges cross each other. So that's why this is a planar graph. In planar graph, you should keep in mind no edges cross each other, but every edges connect with every vertex. In third graph, try. You take all these points 1, 2, 3, 4, 5, 6. First of draw lines from vertex to vertex. Now first cross. If you want to you do not want to cross it, you can take this line outside, but you can take from this line. I will again draw. You can see when we draw these lines, when we draw, if I draw this line here, and if you want to draw this line will be cut, this line will be cross this line. I draw this outside, and if you want to draw this line, then it will be cut. When we take it outside, then it also cut this line. So that's why we can say it is a non-planar graph, because in this edges cross each other. So that's why this question's answer is G2. Graph 2 is a planar graph. Now I am going to discuss in detail about some concepts related to it. You have to keep in mind second graph, which is a planar graph. That graph is also known as isomorphic graph. It divides the planes into one or more edges, one or more regions, and regions may be finite or infinite. Those regions which have finite edges, that is known as finite region, and in which we draw infinite edges, that is known as infinite regions. And no edges cross each other for the planar graph. Here you can see this graph is given four nodes. This is a complete graph. If you want to draw again new graph without crossing the edges, then you can draw like this. And here you can see 1, 2, 3, 4. Outside region is also included. Here R4 is a infinite, and R1, R2, R3 are finite regions. These are the fixed, and outside region is a infinite region because it has no limit to spreading. So it is a this is a planar graph, and graph 3 is a isomorphic to like the K33. K33 graph is a first graph in which we take the 3 nodes above, 3 nodes below, and we can take the 3 nodes left side, 3 nodes right side, and draw these lines. And when we draw each and every lines with each with the combinations of all the you can say all the nodes, that is that will be not non-planar graph. And we so we can say it is a non-planar graph. So it is non-planar graph. Now next, related to it some points more. There are some properties of a planar graph. Some properties of planar graph which should we keep in mind when you check the planar graph given graph is a planar graph or not. First property we should be keep in mind that if a graph is a connected graph, if your graph is a connected graph, then its regions must be less than equal to 2/3 of its edges. 2/3 of its edges. It's a rule. If a graph, if when you draw a graph and that graph is a connected graph, then its region must be less than equal to 2/3 of its edges. And there are some more rules in connected graph. First rule is it should be follow this rule. Vertices minus edges plus region is equal to 2. When you put vertices or edges or regions, then that should be equal to 2. When we solve this equation, that should be equal to 2. If it is equal to 2, then we can say that it is a connected graph. Then we can say that it is a planar graph. It should be followed another rule. 3v minus e greater than equal to 6. You can also follow this rule. If a graph is a complete graph, if your graph is a complete graph, then you can check how then you can check whether it is a planar graph or non-planar graph. You can check it. Only this condition is given. If, planar if and only if n is less than 5, means number of nodes if less than 5, then you can say that this complete graph is a planar graph. Then you can say that this graph which is given complete graph which is a planar graph because its nodes are less than 5. And next, in fourth point, if a graph is a complete bipartite graph, if graph is a complete bipartite graph, bipartite graph, KMN is a planar, means complete bipartite graph is a planar graph when if and only if its m is less than 3 and n is greater than 3, means m's value should be less than 3 and n's value greater than 3. Then you can say bipartite graph is which is a bipartite graph which is a complete graph, and that will be planar graph. You can say that should be like this, 2/3. 2 by, you can say 2/3 greater than 3. You can take here 4. You can match, draw, try to draw, or you can draw outside it, or you can draw it. You can't see, you can't say less than 3 and greater than 3. That means you can take it like this. or you can take like this. You can see here no edges cross each other. So that's why we can say this is a complete bipartite graph, which is a planar graph. Now next example is given. We have given K4 graph, which is a complete graph, is a planar graph. Why we say it K4 graph? K is given for name for complete graph. That graph which is a complete, that is known as a K. We take it is a we take a abbreviation K. You can take any name. And why we should say that is a K4? Because it has 4 nodes. Because it has 4 nodes. That's why we say that it is a K4 graph. And it is a planar graph. You can put these rules and check whether it is a planar graph or not. All rules will be implemented or not. You can implement first rule V minus E plus R is equal to. You can see 4 is the total vertices and E is the total edges. 1, 2, 3, 4, 5, 6 and R is given 4 and 1, 2, 3, 4 and is equal to 2. When you solve 4 plus 4, 8, 8 minus 6, 2, 2 is equal to 2. That's why we can say that it is a planar graph. Now we will be put in second rule. 3V minus E, that should be greater than equal to 6. 3 multiply 4, 12. 12 minus 6, 6 is greater than equal to 6. Yes, it also for satisfies this rule. And the next rule is edges is given 6 and nodes are given 4. And nodes are less than 5. Yes, 4 there are 4 total nodes. That's why it also satisfies these rules. So we can say this is a planar graph. This graph which is given complete graph, that is a planar graph. Now how to find out non-planar graph? If it cannot drawn in a plane so that no edges cross, that is known as a non-planar graph. We can say we have given K5. This is a complete graph. Can we draw it again without crossing each other? No, it does not. It cannot draw any new graph in a plane without crossing edges each other. You can try it. You can see here we take 5 edges. First of all, I will join all the nodes by edges. First, I draw this line. When I draw this line, this will be cross. So I draw it outside. When we draw this line, it will also cross each other. I draw it from outside. Now, how can draw? Now, you can see we have given 2 lines, these lines. First line I draw easily. But this last line, how can draw it? I can't draw it outside because if I try to draw it outside, it also cross this line. When we draw it inside, then it cross this line. So that's why we can say that K5 is a non-planar graph. It does not follow the rule of planar graph. In planar graph, we should not be cross each other. We should not be take such type of edges which cross each other. Now, what are the properties of non-planar graph? It is a non-planar graph if and only if it contains a subgraph homeomorphic to K5 or K33. That is K55 and K33. You have to keep in mind that K55, K33 both are non-planar graph. These are given 6 vertices graph and it also known as 3 by 3 graph, and this is also 3 by 3 graph. Both graphs are non-planar because we cannot draw this graph again, new graph without crossing the edges each other. You can check it by these rules which are given in a planar graph. Vertices are 5, edges 10. First rule, 3v minus e is greater than equal to 6. You can see 5 is less than 6, that's why it does not follow this rule. V minus e plus r is equal to 5 minus 10 plus 11 equal to 2. 6 not equal to 2. So that's why it does not satisfy this rule. And in third rule, V vertices should be vertices you can say reasons that should be less than equal to 2 by 3 of E. Here you can see vertices are 5 and 2 by 3 of E. When we calculate it, it does not equal to. So that's why we can say that it is a non-planar graph. Now next point, or you can say next question. Next question is the number of distinct simple graph with up to 3 nodes. We have to find out here number of distinct simple graph. Distinct means different simple graph. We have to find out number of different simple graph with up to 3 nodes. Its answer is 7. How its answer is 7? We solve it by this method. First of all, suppose vertices are unlabeled. All vertices are unlabeled and number of distinct simple graph with one node. Only you have given one node. Then with one node, you can say, you can draw any graph or not? No. Number of distinct simple graph with you can draw only one node. And 2 nodes, you have given 2 nodes. You can draw 2 graphs without edges or one edge. With one edge, one graph will be drawn and another graph will be drawn with no edges. And when number of distinct simple graph with 3 nodes, then you can draw 4 types of graph without edges, and 1 edge graph, 2 edges graph and 3 edges graph. Therefore, total number of distinct simple graph up to 3 nodes. One node graph, 2 node, 3 nodes. Then when we add all these, that will be equal to 7. You can also use this formula. Number of distinct simple graph 2 raised to power n minus 1. 2 raised to power 3 minus 1, we find out 7. Or other formula is the number of simple graph possible with n vertices, 2n C2. 2n bracket start n minus 1 over 2. Here you put 3 nodes, 3 minus 1 2, 2 ones are 2, 3. 2 raised to power 3, that is 8. And 1 minus with you can find out number of simple graphs possible. How much simple graph possible you can be find easily. Now I am going to discuss next for solving next question. I am here discussing about what is a graph. There are multi type of graphs. You can say it is a null graph, trivial graph, non-directed graph, directed graph, disconnected graph, connected graph, regular graph, planar graph, non-planar graph, and Euler graph, Hamiltonian graph. There are so much type of graphs which are given in in a discrete structure. Here I am going to discuss first, that is a null graph. Null graph which having no edges, that is known as a null graph. You can see here dot A vertex, B vertex, C vertex, which are not connected with each other and there is no edges, that is a null graph. Trivial graph, only one vertex, that is known as a trivial graph. Non-directed graph which contains edges, but edges are not directed ones. That means there is no direction from A to B it has to go it has to go A to B, or it has to go A to D. There is no direction. When there is no direction given, that is non-directed graph. And directed graph means each edge has a direction. For example, here I have given A to B. I have given direction A to go to B, and B to C, C to D, D to A. This is a direction given in a graph, that is a directed graph. And in a directed graph, AB is not equal to BA, and BC not equal to BC, or not equal to CB, and CD not equal to DC, DA not equal to AD, because they go to this side, they cannot go to this side, because direction is given one. And undirected graph, AB is equal to BA, BC is equal to CB, CD is equal to DC, AD is equal to DA. Now next is a connected graph. What is a connected graph? Connected graph means there must be exist path. There must be exist path between every pair of vertices. That is a connected graph. At least one edge for every vertex in graph. At least one edge for every vertex in the graph means this is a connected graph. When we connect this node, this node, this node, this is a connected graph. And so that we can say that it is a connected graph. And in next point is, next graph is a simple graph. What do you mean by simple graph? There is no loops, no parallel edges. Maximum number of edges will be possible in a single or simple graph. For this we will be use this formula NC2 or n bracket start n minus 1 over 2. You can use this formula, either you can use this formula. Number of simple graph possible with n vertices, then you can see this formula 2 raised to power n C2, 2 raised to power n bracket start n minus 1 bracket close over 2. And the next type is given regular graph. Regular graph, if all its vertices, if it's all vertices same degree, means this graph is a regular graph because its degree is same. Each node has 2 degrees. Degree means number of edges, one node which is connected with number of edges. If this node is connected these edges, its degree is 3 sides connected. And next is a disconnected graph. If it does not contain at least 2 connected vertices, means we take here 2 vertices but we cannot draw any edge, that is known as a disconnected graph. You can say that you draw these 2 complete graphs, but you do not connect with each other. Do not connect, make here any line. That is, then we can say that these 2 graphs are disconnected graphs. And the next type is complete graph. Now, in detail, I am going to discuss about complete graph. A simple graph with n mutual vertices. Mutual means independent vertices. Independent vertices, that is known as a complete graph. And complete graph denoted by a Kn. A vertex should have edges with all other vertices. Means each and every vertex is connected with each other through the edges. We can say that if a vertex is connected to all other vertices, if one vertex is connected to all other vertices in a graph, then it is called a complete graph. You can see here A vertex is connected with B and A connected with D. On the other side, B connected with A and B connected with C, and C connected with B and C connected with D. So that is called complete graph because each and every nodes in this graph connected. Now next type of graph is cycle graph. And this graph, we take notation for it Cn. when in a simple graph n vertices, when in a simple graph n vertices which is greater than equal to, which is greater than equal to 3, then and edges is called a cycle graph if all its edges from a cycle of length n. If degree of each vertex in the graph is 2, then it is called cycle graph. Here you can see this is also a cycle graph because each vertex degree is 2. So you can say also this is a complete graph, this is a cycle graph. Now, next is example of this. Here we take A, B, C, these 3 vertex and combine. When we combine it, this make a cycle. A to B, B, C, C, B, C to C, A. This is a cycle which start from where it start, it will be end there. And A to B, B to C, C to D, D to A. Starting and ending point are same in cycle graph. Wheel graph, that is denoted by Wn. That is denoted by Wn and it is derived from cycle graph. You should be keep in mind that wheel graph is derived from cycle graph. And how to derive it? In cycle graph, when we minus 1 by adding a new vertex, that is known as a Cn minus 1. That means one new vertex add, we make a wheel. New vertex is like a hub. New vertex is like a hub. It connects with all vertices of cycle graph. And number of edges in Wn means wheel graph is equal to number of edges from hub to all other nodes plus number of edges from all other nodes in a cycle graph without hub. Both are added, then we can get number of edges in wheel graph. You can take here example. This is a cycle graph. When we add one node here, it draw all other edges and connect this graph with, and this is a wheel graph. And number of edges in this 1, 2, 3, 4, 5, 6. How to calculate? 2, n is 4 because nodes become 4. 1, 2, 3, 4. 4 minus 1, 3. 3 2 is 6. So you can check edges will be 6. So that's why we can say that it is a wheel graph. When we add one node, it convert into from cycle graph to wheel graph. Now next point is cyclic graph. A graph with at least one cycle. A graph in which at least one cycle is called a cyclic graph. You can see here two graphs are given which are connected with common node, and this makes a cyclic graph. A, B, C, D, it is already cycle graph. E, B, F, G, already cycle graph. But in this both graphs, in both graphs, there is a common edge is given which is connected both graphs, and that is known as a cyclic graph. You can see there is two cycles graph, A, B, C, D, B, E, F, G. Both are connected by a common vertex, that is B. So it is called a cyclic graph. Now next is a acyclic graph. A graph with no cycle, that is called the acyclic graph. You can see here B is connected. B is used for connection both graphs, but both are acyclic graph because A, B, C does not connect with D. Here E, F, G, B connected, but B does not connect with E. So it has no cycle graph whether they are connected by a common vertex B. Now next is what is a non-cyclic graph? Because it do not have any cycles. It is also known as non-cyclic graph, a cyclic graph, because it does not have any cycles. Bipartite graph means a simple graph, vertices or edges with vertex partition. When we make a vertex partition, for example, we have given 6 vertices graph and we partition 3 vertex. We take 3 vertex and cross these vertex each other, and we cross each other such a type it can be connected with each other nodes by their edges. That is known as bipartite graph. And bipartite graph, when every edge of for example, we have given these 4 vertex 1, vertex 2, vertex 3, vertex 4, and we connect vertex 1 with vertex 3 and vertex 2 with vertex 4, and you can draw from this graph again V1, B3, B2 and B4. You can draw it. When every edge of E joins vertex in V1 to vertex in B2, means every edge it has one edge that is connected like this. This has one edge that is connected like this, and this definition is say that when every edge of E joins a vertex in V1 to vertex in B2, that is known as a bipartite graph. You can see here example again. We can observe 2 sets of vertices V1 and B2 and 2 edges AD and BC connected the vertices of 2 sets V1 and B2. Now complete bipartite graph. What do you mean by complete bipartite graph? When every vertex in V1 which is connected to every vertex of B2, that is known as a complete bipartite graph. If V1 is equal to M and V2 is equal to N, then complete bipartite graph is denoted by K, M, N. K, M, N. M is a vertices, N is a edges. K, M, N, you can write it M plus N also. When M is equal to N, then it is a regular graph, means 3, 3. That is known as a regular graph. Note, you should be keep in mind this note. A complete bipartite graph is not a complete graph. Kmn is a complete graph if m equal to n equal to 1. The maximum number of edges in a bipartite graph with n vertices is n square over 4. If you want to find out maximum number of edges in a bipartite graph with n nodes, for example, we have given 4 nodes, and we have to find how many edges will be drawn in a bipartite graph, then you can find it. 4 square over 4. 4 for the 16. 4 for the 16. You can check 4 edges will be drawn in 4 nodes. 1, 2, 3. You can draw it. You can see there will be 4 edges. If n is equal to 10, if you have given n 10, then you can take m 5 or you can take a 5 and 5. Yani means m and both are equal. And you can check number of edges by putting this formula. N is 10, 10 square over 4. 4 divided by 125 edges. Now you can calculate similarly other number of nodes. If you have given here 3, 2, 5 square over 4, that is 25 over 5. And you can check it approximately 6 edges will be drawn. Case 6 4, that means 10. 10 square over 4, 100 by 4, 25. If and you can as you can check easily. 6 4s are 24, 7 3s are 21, 8 2s are 16, 9 1s are 9. You can see here 5 5s are 25, 3 2s are 6. You can directly calculate how many edges will be drawn. Now next point is, if you have given n 9, you can take pair 5 or 4, 6 or 3, 7 to 9, 8 to 1. And you can check number of how many edges will be drawn. It's when you take 9 square over 4, 20 edges. When you take here 6 or 3, if you change the pair 6 or 3, 6 3 is the 18 edges, 7 2 is the 14, 8 1 is the 8 edges. G is a bipartite graph of if G has no cycles of odd length. If G has no cycles of odd length, then you can say the graph which is drawn, that is a bipartite graph. And special case of a bipartite graph is a star graph. Special case of a bipartite graph is a star graph. In this graph, m will be 1 and n will be n minus 1. A complete graph which is a form of k1 or n minus 1 format, that is known as star graph with n vertices. In this case, one vertex which belongs to one set and other remaining vertices belong to other sets. You can see here you have a given one vertex that is connected to other stars, other vertex. This is known as a star vertex, star graph. Here out of n vertices, all n minus 1 vertices are connected to a single vertex. It is connected to a single vertex. Hence it is a form of k1 n minus 1 which are star graph. Now next graph is a complement of a graph. What is a complement of a graph? When edges that exist in a graph are absent. When edges that are exist in a graph are absent in another graph, if both graph 1 and 2 are combined together to form a complete graph, then graph 1 and 2 are known as a complement of each other. For example, here we have drawn one graph like this. I have drawn this graph G1, and here I have drawn this graph, that is a G2. When we combine it, it will be drawn like this. And this is a third graph that is known as a complement of each other. When we combine both, then we draw it. That is known as a complement of each other. So here you can see in one graph these two sides are absent, and in a second graph these two sides are given, which are absent here, these are present here, which are present here, these are absent here. And when we combine both graphs, that is that make a new graph, complete graph, that is known as a complement of each. So we can say that it is a complement of each other. You can see here combination of both graphs gives a complete graph, and G3 is equal to G1 plus G2. A combination of two complementary graphs gives a complete graph. When we combine the two complementary graphs, that is known as a complete graph. For example, G1 is equal to 9 vertices. We have given G1 which is equal to 9 vertices and 12 edges. Find the complementary graph of number of edges G1 and G2. You can find it by G3 is equal to G1 plus G2. Number of edges of complete graph, that should be equal to number of edges of simple graph plus number of edges of complementary graph. We have given 12 edges, that is simple graph, and graph 2, that is a complementary graph, and a number of edges of complete graph, we have a given formula n minus 1 over 2. Here substitute the vertices value, and you can find here 36 is a number of edges of complete graph, and out of these edges we will be subtract the number of edges of simple graph and we will find the complementary graph's edges. That is a 24. You can find this. Another example, how to calculate the number of nodes of a complete graph and how to calculate the number of complementary graph. You have given simple graph 40, number of edges 40, complete graphs edges 78, complementary graph you can find it G2 is equal to G3 minus G1, that is a 38. Now number of, how to calculate the number of nodes of a complete graph, that you can use this formula. Here we have given 78 is a number of nodes which is a which of a complete graph. You can put it here left side and equal to n minus 1 by 2. N multiply n, that is n square, and n multiply 1, that is n square minus n is equal to 78 multiplied by 2, 156. N square minus n minus 156 is equal to 0. You can make you can draw the factors and make the make pairs. That will be make pairs 12 13s the 156. You can see here the n is a 13, negative number is ignored. That should be ignored. Now next question. The 2 raised to power n vertices of a graph. We have given 2 raised to power n vertices of a graph G correspond to all subsets of a set of size n for n greater than equal to 6. 2 vertices of graph are G are adjacent if and only if corresponding sets intersect in exactly 2 elements. In exactly 2 elements. Here the number of vertices of degree 0 in a graph. The number of vertices of degree 0 in graph G we have to find out. For finding this we use this formula n plus 1. We use this formula n plus 1. We can find number of vertices of degrees zeros in graph. How many graphs will be drawn? Now reason is, I explain it here, reason why we use n plus 1. Assume G1 contains n elements. Then G1 has 2 raised to power n subsets. Graph G2 contains 2 raised to power n vertices. And assume G1 is equal to V1, V2, V3 up to Vn vertices. 2 graph of G are adjacent if and only if corresponding sets intersect and cut in exactly 2 elements. Exactly 2 elements. Then you can say, here we can use this formula. Vertices 1 intersect vertex 2 and equal to 2. Means when we solved it, it should be equal to 2. Subset must have at least 2 elements. Means those subsets in we use in for making the graph, that should be at least 2 elements. We should take this note in keep in mind. The number of vertices of a degree 0 in a graph is 1. 0, if you have given 0 node, no node, you have no given any node, then you can say, you can draw null null subset. Means only one subset possible, that is null. When you have given one node, you can say it will be 1, it will be 2, it will be 3, it will be 4, 5, 6 and a number of nodes. You can say, you can keep in each curly braces number of nodes, that is equal to n. 0 node plus 1 node. 0 node, when we add 0 node plus 1 node, that is known as n plus 1. 0 node denoted by n and 1 node plus. So that's why its option is C is answer. Note. Number of vertices with degree 0, when we have to find number of vertices with degree 0, that should be equal to number of subsets with the size that should be less than equal to and n plus 1. This formula is very important. You should be keep in mind because it is used for solving the question of numeric. Now next question is, we have given in this question also 2 raised to power n vertices of graph which is correspond to all subsets of a set of size n. N is greater than equal to 6. 2 vertices of a G are adjacent if and only if corresponding sets intersect exactly 2 elements. Same. But in this question, we have to find out number of connected components in a graph. In previous question, we find out number of vertices with degree 0 and number of sets. In this question we have to find out number of connected components in a graph. Then we use formula n plus 2. Then we use formula n plus 2 because because we have need 2 nodes, at least 2 nodes for the making connection. So that's why we can say that n plus 2. The reason is the number of connected component of G is determined by degree and edges of vertices there are. Edges of vertices there are n plus 1. And vertices whose degree is 0, so they can form n plus 1 connected component. The remaining vertices of graph G are all connected as a single component. So total number of connected component is n plus 2. This is formula for finding the connected components. And in the next question, in a binary tree, we have given a binary tree with n nodes. Every node has an odd number of descendant, means child. Every node is connected to be its own descendant. Every node should be connected with its descendant, not with other descendant. Only one descendant it should be connected. And what is the number of nodes in the tree that have exactly one child? That should be 0. Why? Reason is that a tree with one node is not possible. It is given that every child has exactly one child. Every child exactly has one child. If n is equal to 2, if nodes are 2, then you can form a tree. A's descendants is B. If n is equal to 3, then A has 3 descendants, 1, 2, 3. B has 2 descendants, 1, 2. C has a 1 descendant, 1. It does not have odd number of descendants. So we can say that tree with 4, 5, 6 nodes, it is not possible to have all nodes with odd number of descendants. So that's why we can say that here 0 answer. Now next question is, K4 and Q3 are graph with the following structure. We have given 2 graphs, K4 and Q3. Which one of the following statement is true in relation to these graphs? Out of this we have to find which statement is true. K4 is a planar while Q3 is not. Both K4 Q3 are planar. Q3 is a planar while K4 is not. Neither K4 nor Q3 is planar. Answer is both are planar. How? You can draw the new graph from both. So that's why it is a planar graph. Next question. In next question, let G be a simple undirected planar graph. G is a simple undirected planar graph on 10 vertices and 15 edges. How many vertices? 10, edges 15. It is if G is a connected graph, then number of bounded faces in any embedded of graph on the plane is equal to, we have to find out number of faces. Here you can use this formula and you can find answer is 6. V is 10, E is 15, R is R you have to find out. 2 is given in formula. R is equal to 2 minus 10 plus 15, and that is a 7. Total regions are 7, and number of faces equal to regions minus 1. Regions minus 1. Then you can find out bounded regions, that is 6. Now next question is, the maximum number of edges in a bipartite graph on 12 vertices is. If you have given bipartite graph with 12 vertices, then you have to find out number of edges. And for finding maximum number of edges in bipartite graph, we use this formula n square over 4. 12 square 4, 144 over 4, and you can get 36 is the answer. That is the answer is C. Now next question is, the number of distinct minimum spanning tree. We have to find out here number of distinct minimum spanning trees for weighted graph. In a spanning tree, we have to find out, first of all, keep in mind that we should be choose smallest weight number. We should be choose all smallest weight number, then you have to choose next greater number. If all edges, if all vertices are not cover up. You can see here I have taken all vertices. I have taken all 1 vertices, and 1 vertices I have taken here 2 only, because it is necessary to connect with it. Take all weight 1 because they do not make a cycle graph. Here you should we keep in mind that in spanning tree there should not be make a cycle graph, and weight 2 edges can be chosen in also, because it makes 1 2 3 4 and 1 2 3 3 we have a 1 vertices, 1 weight vertices, and 1 is a 2 vertices, 2 edges. When we multiply, we get the 6 ways. This is the answer of this question. Now you can see there are 6 possible minimum spanning trees. You can draw 6 possible minimum spanning tree from this spanning tree. And in next question, let delta is denoted by the number of degree. Let delta denote the minimum degree of a vertex in a graph for all the planar graph on n vertices with the delta greater than equal to 3, which one of the following is true. Here you have to keep in mind that first statement is given, is any planar embedding the number of faces is at least n by 2 plus 2. In the second, is any planar embedding their number of faces less than n by 2 plus 2. There is a planar embedding in which number of faces is less than n over 2 plus 2. There is a planar embedding in which number of faces is at most n over delta plus 1. All these definitions are wrong. These definitions are false, because reason is that in first equation we have in first statement we have given, if is any planar embedding the number of faces is at least n by 2 plus 2. We take here Euler's formula, v minus e plus r is equal to, and we take instead of v, here we write n notes, we take here formula e minus n plus 2 is equal to, you can put here, you can see here that it will be equal to 3n over 2, 3n over 2 minus n plus 2. And when we take LCM, then we find out n plus 2 over 2. And you can separate it, n by 2 plus 2. Now next question. Consider a binary tree. T has 200 leaf nodes, and then number of nodes in T have exactly 2 nodes children. When we have to find exactly number of nodes of degree 2 in any binary tree, then you can use this formula. Number of leaf nodes minus 1, you can find number of nodes of degree 2 in any binary tree. So that's why its answer is 199. The minimum number of colors that is sufficient to vertex color any planar graph, that will be 4. How? Four color theorem say that every planar graph can connect with the 4 colors. 4 colors are sufficient property color. So that's why it is a answer is 4, which is a minimum number of colors that is sufficient to vertex color on any planar graph. 4 colors. You can take example here. There is a 4 vertex. If we take here red, I can't take here red. I can't take here red. You can take here green color. Here can blue. Here you can yellow. Because if we connect with it, then here you cannot take the red. If we connect it with this, you cannot take here green or yellow. Same. So that's why 4 colors are needed in a any planar graph. Let T be a tree with 10 vertices, the sum of degree of all vertices in T. For calculating this degree, we use this formula. 2 multiply number of edges, n minus 1. 10 minus 1, 9. 9 to the 18. This is a fixed formulas. You have to learn these formulas for calculating the degree. Now next question is, which is related to probability. A bag has 4 red, 5 black balls. A second bag has 3rd red, 3 red and 7 black balls. 1 ball is drawn from first bag and 2 balls from second bag. The probability that there are 2 black balls and a red ball. And answer is 7 by 15. How it is calculated, I can show you. Reason being, first we take a probability that a ball from bag. When we draw bag A and this is a bag B. First we take a probability that when we draw this from this bag, 1 is a red ball and total red ball are 4. Out of total 4, 1 is a red. And I take both balls from bag B. Both balls from bag B, that should be black. So that's why here I am taking 7 by 7 C2. And in over, when we draw from bag 1, in bag 1 total balls are 9. Out of 9, 1 is a red ball. And in bag 2 total balls are 10. So that's why 10 C2 here I am taking. And plus probability, a ball drawn from bag A. Bag is a fix. That is we have to take one from a bag. We can take only one ball. That should be either red or black. Here I am taking red. Here I am taking a black ball. So 5C1 over 9C1 multiply. And but in a second bag, I am taking 2 balls. 1 red, 1 black, because 1 red must there should be must withdrawn. So that's why here I am taking 1 red ball and 1 black ball, because 1 black ball is withdrawn from the bag A. In second bag we take 2 balls, 1 red and 1 black. 3C1 multiply 7C1 over 10C2. Now you have to solve this combination. 4 factorial over formula is taken here, n factorial over r factorial n minus r factorial. So this is a r and this is a n. So put this formula in this so put the values in this formula, and you can be find after solving these all equations. You can see here in detail I have solved. You can see at the end we will be get result 28 by 135 plus 35 by 135. When we add it, we find 63 by 135, and 9 7 is the 63, 9 15 is the 105. You will find 7 by 15 is the answer. Now next question is, 2 dice are thrown simultaneously. 2 dice are thrown simultaneously. What is the probability at one them will have 6 facing up. We take here answer is 11 by 36. How? Probability of at least one of dice will have facing 6. 1 minus P, none of dice have 6 facing. That is 5 by 6 over 5 by 6. You can see those dices which does not follow, which does not face up the 6, that is the 25 by 36. That means others are 2, 4, 3, 3, 4, 2, 5, 1, 5, 1, 5, and you can see, or 2, 4, 3, 3, 6, 6, 1, 2, 3, 4, 5, 6, 6, 1, 1, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9. You can see 3, 4, 4, 5, 5, 5, 1, 6, 1, 1, 6, 6, 2, 2, 6, or 4, 6, 3, 6, 1, 6, 1, 2. Just a minute. I have drawn here pair. You can see 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. You can see these are those numbers in which 6 faces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's why answer is 11 by 36. And 25 are those numbers on which 6 face up is not present. So that's why you can use this method, you can use this formula for solving the question. Now next question is, the number of ways in which 8 distinct toys can be distributed among 5 children. Each toy can be distributed in 5 ways. So total number of ways will be, how many distinct toys? 8. Ways 5, 5 raised to power 8. That formula should be taken here for finding the result. Everybody in room shakes hands with everybody else. The total number of handshakes is 66 is given. Total number of persons in the room is, that should be 12. How? For solving this equation, we will take a formula. Suppose n person in the room. Total number of handshakes is the same as the number of ways of selecting 2 out of n. N C2 is equal to 6. 2 persons there should be present for handshake. So that's why R is equal to 2 and N is equal to, here we have to find N, and total given is 66. When we by cross multiply, we find n square minus n is equal to 132. And after solving this, we will find person is, that is number of 12. Now next question is given. In this question, if 35cn plus 7 is equal to 35c4n minus 2, then find the value of n. And n's value is 3, 6. How? You can find it. 35cn plus 1 equal to 35c 4n minus 1. This one cut with this one, and we remaining value n plus 7 is equal to 4n minus 2. N minus 4n is equal to minus 2 minus 7 minus 3 minus 9 minus minus cut, and 3 is the 9. N is the answer. Now next is a consider the following two statements. If a candidate is known to be corrupt, if a candidate is known to be corrupt, then he will not elected. Then he will not elected. If a candidate is kind, he will be selected. Which one of the following statement follow S1, S2 per sound interference rules of a logic? Here we take, if a person is known to be corrupt, he is kind. That if a person is known to be corrupt, that is represent to P, and he is a kind, that is represent R. Here statement says, if a person is known to corrupt, then he is kind. P implies R. If a person is not known to be corrupt, that means be not P, and he is not kind, not R. So statement will be represent like this. Not P implies not R. If a person is kind, he is not known to be corrupt. That means not P. R implies not P. If a person is not kind, he is not known to be corrupt. Not kind means not R, and not corrupt. Not corrupt means not P, and it implies some. So here we will be take answer is C. This is the answer. Why? Reason is behind. S1 statement says P implies not Q, R implies Q, and result is P implies R and not P or R. And from this statement, from this statement show R implies not P. That means result will be verified with result will be verified. R implies not P, and P implies R means not P or R. I repeat it again. Here a candidate is known to be corrupt, that is represented by P. He will not be elected. He will not be elected, not Q. And a candidate R will not elected, will be selected, Q. P R implies Q, and according to statement, here I have given these two statements. When we solve it, you can solve it like this. This will be finished. P implies R. When we solve it, we find this, and this answer is matched with this well. This with this. Now next is, let R be the relation on set of positive integers. Let R be the relation on set of positive integers such that A relation B if and only if A and B are distinct, have a common divisor other than 1. Which one of the following statements about R is true? Here answer is first, that is true. Why? How? R is a symmetric. This statement says R is a symmetric and reflexive but not transitive. R is a reflexive but not symmetric and not transitive. R is a transitive but not reflexive and not symmetric. R is a symmetric but not reflexive and not transitive. Now here in this question I am taking that R is a reflexive. For example, I am taking R is a reflexive because we have given 3, 3. This is a reflexive. Is an element which have a common divisor, that is 1 or 3. So relation. So relation is a reflexive, and relation is symmetric. 3, we take here 3 6 or 6 3, both have common divisor rather than 1, that is a that also present, but not transitive. Not transitive R is a symmetric, but not transitive R is a symmetric. How? You can take here A3 B6 C8. Common divisor of 3 and 6 is 3, and common divisor of 6 and 8 is 2, and there is no common divisor of 3 and 8. So that's why we can say that 3 belongs to 6 but not belongs to 8, so it is not a transitive. So answer is a first equation. Now next is a next question is, if A and B are two sets, if A and B are two sets, then A intersect A union B equals, to which equal? First solution is, we have take here two sets, A 1 2 3, B 2 3 4. A intersect A union B means, first of all we have to solve union. In union we take all common values and all remaining values. First we take first set's value, all first set's value, and take the second set's value which is not common, that is 4. This is a union. When we take intersect between A and A union B, we find that when we take only intersect value, we take only first set's value, that is 1 2 3, that is A. So that's why you can see it match. So that's answer is A. Now next is a, let we have given let A given x is a multiple of 3, means in x first set we have take 3's multiple values, we take here 3's table, and in set B we takes the 5's multiple, because in question they said that x is a multiple of 5, and we after that we have to find out A intersect B. When we write the all multiples of 3's and 5's, we find that out of the both sets only 15 30 from 15 30 45 values are taking common, and before these values there is no common value which we can extract from out of these two sets. So that's why 15 30 45 is the answer. C is the answer. Now in next question, give the relation R. We have given a table R relation, that is 1 or 2 2 or 3. We can find it from transitive 1 or 3. On set A, we have given set A the minimum number of ordered pairs. How many number of ordered pairs we find out, which when added to R make it an equivalent relation. We can find it by this method. Set A we have 1 2 3. From set A take a relation that is given 1 2 2 3, and from this relation you can draw a new set, that is a 1 or 3. Here 1 2 which is belong R, 1 2 is belong to R, yes belong, and 2 3 is also belong to R, so it is a symmetric. When two sets which which are taken from a main sets, that these both are sets related to one table, that is known as a symmetricum. And in a reflexive we can say 1 1 2 2 3 3 2 1 3 2 2 3 and 1 2. These all will be transitive, because when we take 3 1 or 1 3, both are the belong to R. Thus R becomes an equivalence relation by adding 1 1 2 2 3 3 2 1 3 2 1 3 3 1, and the total number of ordered pair is 7. Total paired of number is paired number we have to find out. These are the total 7. From this relation we can draw from this relation total paired of order, that is a 7. Now how to find it without these all these calculations? You can write 2 raised to power 3 minus 1, that is 8 minus 1, 7. You can take here formula 2 raised to power n minus 1. Now next question is, in a group. Now this question is taken from a group theory. In the group G, we have given a group G 2, 4, 6, 8 under multiplication modulo 10. The identity element is, we have to find identity element. Identity element, that element where this statement will be get as it after dividing the multiplication modulo by 10. You can solve it by this method. You can draw a table. First of all, you have to write given statement, statement that is given 2, 4, 6, 8. You have to write both sides in a row or column wise, 2, 4, 6, 8, and which number is used for the division, that is the 10. So 2 2s are 4, 4 divided by 10, remainder is 4. 2 4s are 8, 8 divided by 10, remainder is 8. 2 6 are 12, divided by 10, 2 is remainder. 2 8s are 16, 6 is the remainder. Now here you can see 4 2s are 8, 8 remainder. 4 4 16, 6 remainder. 4 6 are 24, 4 remainder. 4 8s are 32, 2 remainder. Divide by 10, we have to divide by 10 like this. All these values will be find. After that you have to check original value where will be lie. This line, in this line original value is lie, so that's why 6 is the answer of identity. Now next question is in this question, Z is the set of integer. We have given set of integer that is denoted by Z comma star is a group with the A multiply B is equal to A plus B plus 1. That is given A comma B belong to group, and then inverse of A. We have to find inverse of A. Answer is minus 2A, minus 2 minus A. How to find it? For this, first of all, suppose E will be the identity element. We assume here E is a identity element. Then on the left side, we take this statement from the left side, A multiply B. Put the value. When we put value B is equal to B, E, A multiply E is equal to A, because for all A belongs to group. A plus B plus 1. Here we put B's value E, A plus B, A plus E plus 1, and here you can see A plus 1 on the right side minus 1, A minus A plus a cut minus 1. E's value will be minus 1. Let X be the inverse of A. Here we assume X is the inverse of A. You can write it like this. A is inverse. You can it will be represented by X. And here A multiply A inverse minus you can take here A multiply X. X is given A. We have given A plus B plus 1 is equal to E. On the right side, E that is minus 1. Minus 1 is A plus B plus 1 is equal to E. A plus B. B here we taken here X plus 1 is equal to E. A plus X plus 1, that is E's value is minus 1. We find it from this. X is equal to minus 1 minus 1 minus A. You can see result is minus 2 minus A. I repeat it again. First of all, you have to assume E is a identity element. Then take left side, put the value B, that is E, and find out A. A multiply E, that will be equal to A. And on the right side, A plus B plus 1, A plus E plus 1. Because here I am taking B's value E, so that's why I am writing here E. and E is equal to -1. We find E's value -1. Now here I am taking A's inverse x. A plus B plus 1 is equal to E, because A multiply B, that is equal to E, and A plus x plus 1 E, x is equal to -2 minus A answer after solving the equation. And next question is, if every element of a group G is its own inverse, then G is finite, infinite, या cyclic or abelian, that is a abelian. We have given A is equal to A inverse. A is equal to A inverse for all A belongs to G. Then for any A comma B which is belong to G, means group A B whole power -1, that is equal to AB, because B inverse into A inverse equal to AB. BA is equal to AB, because B inverse equal to B, A inverse equal to A. And according to abelian's rule, that is, we can say that this is a abelian, because BA is equal to AB, both are same. And in question number 27, in a group G and star, for some A of G, A square E, A square square is equal to E, where E is the identity element, then what is the answer? This answer is equal to A inverse. How? A square equal to E is given. Here A square is equal to, here I am taking A inverse on both sides, multiply. When we multiply both sides, then it will be solved. A square is multiply 1 by A cut with the A square, A is remaining. Here E multiply A inverse, and here you can see E will be, when we multiply both, then it will be converted into A inverse. Now next question is, what is the correct translation of a following statement into mathematical logical? Now I am going to discuss about mathematical logical. What is the correct translation of following statement into mathematical logical? Some real numbers are rational. Here we have to find some real numbers. Real numbers are rational, and answer is this one. There exist. This symbol is means there exist some numbers are real. Some numbers are real which are rational. From first statement we find out there exists x which is either real, or this symbol represent to, or rational, can be both. And second statement says that this symbol is used for all real numbers are rational. This statement says all real numbers are rational. Third statement says there exists x which is real and rational, or you can say there exists a real numbers which is rational. And fourth statement says there exist some number x which is rational, which is not rational, or which is real, rare. In next question, consider the following well-formed formula. Here we have given not for all px, not there exist px, not there exist not px, there exist not px. Which of the following are equivalent? You can solve it. First of all, you have to solve, that you can find out automatically what is the answer. Answer is 1 and 4 are equivalent. How? First question, not for all change into there exist, and px change into not px. Not there exists convert into for all, px convert into not px. Not there exists convert to for all, not px into px. And there exists not px, that will be remain as it. You can see answer which will be match. You can see here answers will be match first and fourth. Now next is a which of the following is not, which one of the following is not necessarily a property of group. Commutativity is not a property of group. Now I am discussing all other properties in detail. First is a group is an algebraic system having property of closed under operation, associative, contain identity elements, exist inverse of the every element. A group G star is a monoid with the identity E, and that the additional property that for every element A belong to G and there exists an element of A belong to group and such that A multiply A is equal to A star A and is equal to E. These all are the equal to each other. Then thus we can say a group is set together with the binary operations. It follows property first, associativity means A multiply B in bracket multiply C, that will be equal to A multiply in bracket B multiply C. Inverse for every element means if we multiply with E, then we say that it will be equal to E multiply A. For every A belong to G, that should be equal. Existence of identity means if A multiply inverse of A, then it will be equal to A inverse multiply A. Now next question is consider the binary relation. Consider the binary relation R. Here we have given x, y, x, z, z, x, z, y. On the set x, y, z, which one of the following true? Answer is R is a neither symmetric nor anti-symmetric, because reason is that for symmetric we have given x, y, x, z, z, x, z, y. If A, B both are belong to relation, then there should be condition B, A must be belong to R. Then we can say that it is a symmetric. Means if A belong to B, A, B belong to R, then there should be must B, comma A should be belong to R. If they both are belong to R, then you can say that it is a symmetric. But here we have given x, y. We have not given y, x. We have given x, z, z, x, but we z, y given but not given y, z. So we can say that here it is not a symmetric. Y, x not belong to R, so it is not symmetric. A, B belong to R, then B, comma A not belong to R to be anti-symmetric. But x, z which is given, in which z, x is also given, and both are belong to R, and so R is not a anti-symmetric. So that's why answer is that is given in question. Now the binary operation is defined as follows. We have given this statement. We have given Q or P's value and P or Q's result. What will be the symbol will be taken here out of these statements? Which one of the following is equivalent to P or Q? P or Q means TT, true, 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 false, true, false, true, that should be true, and false, false, false. That is the rule of OR. But now you have to find out of this statement and out of these results, but which result will be match? Answer is B. How? You can prove it in below. You can see not Q, P, V, Q. PVQ, this is the result. When we take P not Q, then result will be also same. P not Q. True, false, true, 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 false, false. Here taking true and false, true, false. And on the other side, P or Q that is given in question. You can see here false, 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 and FF FTT, and this statement is equal to this statement. So that's why answer is that. You can see again in question we have given, we have to find out this answer, from which statement we find this answer. We have take here P implies not Q. P implies Q will be taken here. Not Q is taken here. True, false, false, true, false, true. P implies not Q. True, true, false, true. This is the answer. In next question, P and Q both are two propositions. We have given two propositions, and which are equivalent we have to find out. First of all, we have given P or not Q. Second is given not of not P, that is equal to P, and change into or not Q, that is also equal. And from this statement you can find it result. Answer is only 1, 2, 3 are matching, so that's why we solved it. When we match P and Q, P or not Q, not P and not Q, and all these have a or. What will we find? This cut with this cut with this, we find P or not Q. And from this you can also find, you can P cut with this cut with this, and you can find this value. So you can see first, second, third will be match and others will not, fourth will not be matching with them. Next, which of the following graphs has an Euler circuits? And Euler circuits means any k regular graph where k is an even number. If a graph has an even number, a complete graph which on 90 vertices, the complement of a cycle on 25 vertices, none of these. Answer is a C. How? You can see the reason. Reason is that a connected graph which has Euler circuit, all of its vertices has even degree, and a connected graph has Euler path, exactly two of its vertices have odd degree. Each vertices, all of its vertices have even degree for this circuit, but in Euler path at least two, exactly two such a type of vertices which have odd degree. K regular graph where k is a even number. K regular graph need not be connected always. The given below graph is a two regular graph which is not Euler graph, and this is so because there is no single walk which covers all the edges. So that's why these are not regular graph, not a Euler graph, sorry. Two components. The complete graph of a 90 vertices. In such a graph, every vertex will have an odd degree that is equal to 89. Hence, it cannot have a Euler path or circuit. So, next point is to get degree of all vertices of complement of 25 vertices, we need to subtract the degree of a complete graph of 25 vertices with the degree of vertices in the original even graph. That is cycle on a 25 graphs. This is the answer. You have to learn these definitions as it. Degree of complement you can find there is 24 minus 2, that is 24. Since every degree is even and it is connected also, therefore graph is a Euler cycle. Now I am going to discuss in detail what is the Euler theorem. A connected graph has an Euler cycle. A connected graph has an Euler cycle if and only if every vertex had an even degree. Even degree 2, 4, 0, 6, etc. It has two meanings in a graph. Theory graph with Euler circuit, graph with every vertex of even degree. What do you mean by Euler cycle circuits? Cycles or circuits. Euler cycles or circles. Euler circle or cycles, same thing. A cycle traversing all the edges of the graph exactly once. Means from here we start, run. It should be not repeating any edge. That has an Euler cycle. Has an Euler path but no Euler cycle, because when we start here like this, we go here, we have to repeat it, then we reach the destination. So it has a path but no Euler cycle. Euler path means a path, not a cycle, traversing all the edges of graph exactly once. Has neither Euler cycle, no graph, no Euler path. There is no Euler path, no Euler cycle. Next point, what is the degree of vertex? Degree of vertex means when one vertex is connected with two, when one vertex is connected with any number of edges equal to degree. Here this vertex is connected with two edges, so that's why its degree is 2. Euler paths example. For example, we have drawn this graph. In this, we start the Euler path. We start here D, E, B, B to C, C to A to B, B to D, D to C, C to E. This is called Euler path. In Euler circle, D to E, E to B, B to C, C to A to B, B to D, D to E, we have to repeat, E to F, F to D. This is a Euler circuit. You can see here D to C will be left. So that's what it is, a Euler circuit. Without repeating, we cannot go there. Euler's formula is equal to faces plus vertices minus edges equal to 2. That should be equal to 2. Number of faces, number of vertices, number of edges always equal to 2. Formula is given here. Now next question is related to relation. A relation R is defined on ordered pairs of integers as follow. We have given xy, R is given ub if x less than u. If this x is less than u and y is greater than v, then R. Then R neither a partial order nor a equivalence relation. How? Second point, say a partial order but not a total order. A total order and equivalence relation. But answer is neither a partial order nor an equivalence relation. Because reflexive property is an essential condition for partial order, total order as well as equivalence relation. That should be followed. Given statement. Given set is not a reflexive as because for all x and y belong to I. xy is not related to xy. Here xy is not related to xy. And next question is, which of the following statement is not correct? For finding this, x plus not xy, we will be dominate it. X plus x not xy will be converted into x plus y. X xy, x multiplied by x not x, that is equal to 0. X multiplied by y xy, that is equal to xy. So it's proved, it's true. It's true, and it is also true, because here we take a common x. 1 plus not y is equal to 0, that's not equal to, sorry, it's 1, so that's why x. When we take here common, then we get this value, and this value equal to left side equal to right side. You can see here, this also proved, this is also true, this is a false, so that's why answer is A. Now next question is, the Boolean expression AB plus AB dash plus A dash C, AC plus AC is not unaffected by the value of Boolean. That is answer B. How? I am taking here A common, B plus B dash, that is equal to 1. A C common, A dash A plus A, that is equal to 1, and A plus C. Now you can see B is independent and it is not affected to values of Boolean variable. Now next question is, the Boolean expression A plus BC equals to, here we solve it. First of all, I am taking this equation. When we solve it, we find this equation, and when we solved it, we find A plus BC. So that's why B is the answer of this question. You can see another result. And next question is, if P, Q are Boolean variables, then P plus not Q, P not Q plus P R, and not P not R plus not Q. We have to simplify it. For simplification, first of all, I have multiply P multiply it, P multiply Q not Q multiply it, then P multiply it, then not Q multiply it, and we find this result. When we solved it, we find it P not Q, and we take a common, that is not Q. Here we P, and here P not Q R. Then again here we can take the common, that will be equal P not Q plus PR, and here we take the PR common, 1 plus not Q, that is will be equal to 1, and this will be written as it. And after that we multiply all these values, we distribute by distributive method, and you can find it that not P not R, P not Q plus PR, that here we take P and it will be equal to 0, and this will be equal to P not Q is 1 plus R, that will be equal to 1, and that's why answer finally P not Q is the answer. Now next question is, what is the maximum number of different Boolean functions involving n Boolean variables? For finding this, we will take the formula. This is the formula for finding what is maximum number of different Boolean functions. 2 raised to power 2 raised to power n. This is the formula. You can learn it. Now next question. Define the connective star for the Boolean variables. X multiply y is equal to x y plus x dash y dash, and let z is equal to x multiply z. Consider the following expression P, Q, R. If we take P is x is equal to y multiply z, and Q is equal to y is equal to x into z, and R is equal to x multiply y multiply z, that is equal, and answer is all are valid. How? We will be solved it here. We solved it. X, y will take 0, 1, 0, 1, 0, 1. Then we z find x multiply y. Then we q find. Then we r find. Then multiply all these. Find. You can see the results are same. And you can say that all are valid. Now next is a some group GO is known to be abelian. Then which one of the following is true? Here answer is C is the answer. This is the answer. How? G is equal to G inverse for every G belong to R. G is equal to G inverse for every G belong to R. G of H, G O H whole square is equal to G square O H square for every GH. And G is a finite color. Why answer this is because GOH whole square is equal to GOH 2 time written. Because group is abelian, so it is a commutative as well as associative. First we take a GO in bracket HOG and H outside, GOH, then GOG, O is outside and GOH in one bracket. Then GOGOHH, G square OH square. This is given in a question. Now next question is, let A be the set of all non-singular matrices over real numbers and let star be the metric multiplications operator. Then A is a closed under star, but A star is not semi-group, and A star is a semi-group but not a monoid. A star is a monoid but not a group. A star is a group but not an abelian. Answer is this. A star is a group but not an abelian. Why? Reasons that in closure property, multiplication of two non-singular matrices is non-singular, and matrix multiplication over non-singular matrices follows the closure property. Associative property, multiplication over any set of matrices which is associative, then it will be solved like this, and these are non-singular matrices. Identity elements, identity matrix I is the identity element for matrix multiplication over matrix, and I is a non-singular. And inverse element for every non-singular matrix, its inverse exists. So for non-singular matrices is inverse element. Commutative matrix multiplication is not a commutative because AB not equal to BA. So that's why it is not a commutative. Whereas we can say that A, B are non-singular matrices, matrix multiplication is not commutative. So A star is a group but not an abelian group. Next question is consider the statements. Consider the statements. P given good mobile phones are not cheap. Q is given for cheap mobile phones are not good. L, P implies Q, that means not P or Q. And Q implies P means not Q or P. And P is equivalent to Q. P is equivalent to Q. And which is correct about LMN? Its answer is LMN. All are the true because reason is given below. We take here G. G for mobile good, C for mobile cheap, P for mobile phones, which are not cheap. When we say G implies C not, means mobile is good but not cheap, then we take it as not G or not C. When we take not common G and C. Cheap mobile phones are not good. C implies G dash. That means not C or not G. G not common, then C in or convert into and G. Means both P and Q are same. So now next P. If we written P implies Q, that is true. Q implies P, that is true. P equal to Q, that is also true. So the answer is O, L, M, N are all true. Now next question is, let PS denote the power set of a set S. Which of the following is always true? We have given these statements and we have to keep in mind that power set should be equal to finite. So that's why this is the answer. Finite always present in any power of a set, and finite is only common element between ps or ps p of ps. So that's why intersection will be equal to finite. Now next question is, consider the set sigma star of all the string over alphabet. Sigma is equal to 0 1 and sigma star with the concatenation operator for strings. Uh, clean star, this is known as clean star. It does not form a group, forms a non-community group, does not have a right identity, forms a group of empty string, is removed from clean star. Answer is does not form a group. It does not form a group. How? You can see here. We have given sigma is equal to 0 1. If we take a clean star 0 1 star, that means epsilon 0 1 0 1 1 0 1 1 0 0 anything. So clean star comma multiplication symbol, concatenation symbol is an algebraic system where dot is used for concatenation is in a binary operation. And so clean star concatenation is a group if only if the following conditions are satisfied. Concatenation is a closed operation. Concatenation is an associative operation. There is an identity and every element of clean star has an inverse. Has inverse. And condition 1. Star is a closed operation because for any belong to clean star, means any string 1 which is belong to clean star and string 2 which is belong to clean star, both strings must be belong to clean star and clean closure. And condition 2, for any string x y z which are belong to clean closure, then x dot y dot z is equal to x dot y dot z. That means so it is associative for example, and x we take here 0 1 and y take 1 1 and z take 0 0. When we implement these values in these equations, we find the same answer. So the both are associative. And third condition, identity, that is represented by e or empty string because of any string which is string belong to clean star, and empty string or equal to string empty is equal to the, you can say identity string multiply identity is equal to identity string. So these are identity exist. Condition, there is no inverse exist for clean star because any string belong to clean star, there is no string inverse, such as when we multiply string with the string inverse, then it will be equal to identity. That should be equal to this. You can say, you can see this, and 1 is equal to identity. Consider the statement. Next question is a, consider the statement, not all that glitters is gold. Not all glitters is gold. Predicate glitters x is true if x is glitter, and predicate gold is true if x is gold. Which one of the following statement is implemented? Now I am going to discuss each and every statement in detail. It is false that every glitter is gold. It is false that every glitter is gold. So some glitters are not gold. Then we can say that at least one glitter object is not gold. And the statement not all that glitters is gold can be expressed as, not for all glitters x implies gold x. That is first question, where for all glitters x implies gold x refers to all glitters is gold. And not symbol means not all. And there exists symbol not glitters x implies gold x. That means not for all x is equal to there exists not all. Here this symbol refers to all, and there exists this next symbol refers to there exists some. A implies B is true. We can say A implies B is true only in the case when either A is false or B is true. A false, B true. Then we can say that A implies B. And not A or B, it is also say something same to a second and third equation. We can say there exists some knot of knot glitters X or gold X. Means there exists glitter X and not gold X. Negation cancellations. Negation cancel with negations and we will find a positive. So that's my answer is last equation, last statement, that is there exist glitters X and some glitters X which are not gold. So that's why D is answer. And next question is, we have given Gx, X is a graph. X is a graph, Cx is a connected graph, which is considered statement. Not every graph is connected. This question is related to previous question. In this question, we will be answer is not every graph is connected means for all x, graph x, not graph for all x, graph x implies not connected. Not symbol is related to every graph and connected. So reason is behind that. We will be solved it under this. We have given first statement not for all Gx, not implies not Cx. When we put here not, when we solved this equation, not for all Gx or not Cx, not cut with not, we get for all Gx and Cx. There exists Gx and not Cx. Some graph are not connected. It is the same. Not for all not Gx or Cx. Same as first. So not for all not Gx or Cx. That means it will be convert. There exists some Gx which are not C. Means question is not every graph is connected, means there exists some graph which are not connected, it means. So that my answer is last option. Now next question is, what is a logical translation? None of the friends are perfect. Answer is D. It's just like same. None of my friends are perfect means not there exist some friends which are perfect. And last question, in this also same method, not all rainy days are cold, means there exist some rainy days, there exist some rainy days and not cold, which are not cold. So this is the answer. So that's why answer is this option. Thank you. If you watch my video, please like and share my channel with your friends so that they can get education related videos. If you like, please like and share my channel with your friends and click on like button. If you want to share with your views with me, then you can comment in my comment boxes. Thank you.